brightly. Okay, Mark, I've been hearing buzz about Microchip's new AI-powered coding assistant. Break it down for me. What makes this different from the ChatGPT plugins I already use for code help?
Energetic. Oh man, Jenny, the hyper-specificity. Imagine having a coding buddy who's memorized every nuance of PIC microcontrollers. That's MPLAB AI. It's not just suggesting code, it's asterisk, contextualizing, times every line with real hardware constraints.
Intrigued. Wait, you mean like it knows the actual memory limits and pin configurations of the chip I'm targeting?
Excited. Exactly. While you're typing, it cross-references the MSP430's technical docs or your SAM-D21's I/O registers. Caught a bug last week, where I mixed up timer modules, and the assistant flagged it mid-keystroke with alternate code.
Impressed. So it's like predictive text, but for hardware compatibility? That's actually genius. But does this mean developers lose touch with the underlying specs?
Thoughtful. Fair concern. But here's the kicker. MPLAB AI surfaces relevant datasheet excerpts asterisk in your editor. Instead of alt-tabbing to PDFs, you're essentially building institutional knowledge through the suggestions. Learned more about Power Debugger protocols through its nudges?
Playful. Okay, but where's the line between helpful assistant and crutch? Are we raising a generation of devs who never fully understand their MCUs?
Laughing. Valid. Though I'd argue industrial engineers still need to validate everything. The real win? Shifting brainpower from syntax policing to system design. Imagine tackling RTOS scheduling complexity because the tool handles register-level boilerplate.
Curious. What's the workflow look like, though? Does it really stay inside versus code like they claim?
Animated. The block diagrams, Jenny. You type a sensor initialization sequence and asterisk bam asterisk. It renders an interactive signal flowchart. No more whiteboard snapshots cluttering your project folder. Best part? Exportable as vector graphics for documentation.
Amused. So the future is AI-generated diagrams that don't look like drunk kindergarten scribbles? Sign me up, but how's the privacy angle? Any worries about code being used to train their models?
Nodding. Microchip swears processing stays local unless you opt into sharing. Their white paper details encrypted telemetry channels with anonymized pauses. Wait, am I becoming their sales representative here?
Laughing. Maybe a little. Let's zoom out. Where do you see embedded AI tools evolving from here? Full hardware synthesis from natural language prompts?
Enthusiastic. Think even bigger. Imagine describing a smart thermostat's requirements in plain English, hitting compile, and getting production-ready firmware with optimized PCB layouts. We're not there yet, but MPLAB AI feels like that first step toward co-designing silicon and software through conversation.
Mock serious. So basically, we're training our robot replacements to design better robot parts?
Grinning. As long as they remember who codes their times off time switches. Beat. But seriously, Jenny, tools like this could democratize embedded systems. Imagine students and hobbyists building complex IoT projects faster than ever. That future looks bright.
Warm. Bright and optimized for low power consumption, no doubt. Thanks for the deep dive, Mark. Now, if you'll excuse me, I've got some PIC 32s to program with my new AI copilot.